Hello everyone, this is Manoj Kumar. We are doing the internship in Emertex Private Limited, and we are teammates are Madan Mohan Reddy, Manoj Kumar, and Guru Srinivas Reddy. We are doing the internship in Emertex. We are from CMRIT, fourth year ECE. We are doing the internship. The project is called Black Box Project. In this internship, first we studied about the introduction to C, because we required a basic concepts of C that useful for doing the project. That's why we studied about the introduction to C, and next we studied about the introduction to microcontrollers, and next we studied the introduction to embedded systems and embedded programming that is required to useful to develop a project, and communication protocols. These are the topics we studied in this internship to build a project or basic concept of embedded systems. Coming to introduction to microcontroller, first we studied about what is a microcontroller. An integrated circuit which is capable of being programmed to perform a specific task. The design normally has restrictions on its memory size, input-output capabilities, and peripheral functions, etc. Next we studied about the introduction to microcontroller. In this introduction to microcontroller, we studied the differences between the microprocessor and microcontroller. In this microprocessor, all are separate components and more flexible and more design complexity. Coming to microcontrollers, all components in single chip, less flexible and less design complexity. Next, how to choose a microcontroller. Based on the applications, performance, price, availability of tools, and the special capabilities, we are choosing the microcontroller. Next we studied about what is embedded system. A combination of hardware and software which is intended to do a specific task can be called as the embedded system. These are the figures and examples of embedded system. This is about the introduction to embedded system. Next, categories of embedded system. In this, there are mainly 5 categories, and first one is standalone embedded system. In this standalone system, there are 2: slave, and a slave is nothing but semi-automated washing machine is considered as slave, and independent embedded system, example Google car. And coming to next, real-time embedded system. Embedded system taking an action within specific amount of time, example airbag system, pacemaker, missile. And next is networker embedded system, example is router, home security system. Next, fourth one is mobile embedded system, example Google car. And fifth one is hybrid embedded system, example robot. Next, previously we seen about the how to choose microcontroller. Now we choose how to choose embedded system based on the low power consumption, cost efficiency, efficient use of processing power, reliability, and efficient use of memory. We are choosing the embedded system. Next we will see the components of embedded system. If you see this figure, this is considered as software and hardware, and is memory, FPGA. Next, diagnostic port, human interfaces, analog to digital converter, and digital to analog converter. It consists of actuators, sensors. Here we are using the auxiliary system. These are the components of embedded system. Next, requirements. Based on this, reliability, cost effectiveness, low power consumptions, effective use of processing power. These are the requirements. Coming to real-time aspects: hard real-time, firm real-time, soft real-time. Hard real-time means should meet its deadline, life critical application. Firm real-time means similar to hard real-time, and it's follow these properties. Soft real-time means can have tolerance in meeting its deadline. Next, in this internship, we done a car black box project. In this project, we are using the softwares or MPLAB XID, XID compiler, and PiximLab. PiximLab is a real-time emulator of development boards with integrated MPLAB and AVR GDB debugger. PiximLab have integration with MPLAB X Arduino IDE for programming the board microcontrollers. For code editing and debugging, the same tools used for the real board should be used with PiximLab, such as MPLAB X or Arduino IDE. These are the softwares are used in this project. This is PIC16F877A. This is the PIC Genius board from Microchip. In this industry, we use microcontroller called PIC16F877A. This is the microcontroller we used in this internship. Its size of bit 8 and it consists of 5 ports. Port A 6-bit, it's analog, and port B 8-bit, it's bidirectional port, and port C 8-bit digital pins used for simulation serial communication. Port D 8-bit, all are digital pins, and port finally is port E, it is 3-bit. In this is the microcontroller PIC16877A PIC Genius board from Microchip. In this we used LEDs, digital keypad, interrupts, timers, clock input, outputs, SSDs, CLCD, matrix keypad, and analog inputs. These are the components. This is the LEDs, this is the potentiometer, these are the switches we used in CLCD and digital keypad. This is the CLCD, and timers also we used to show the time, and clock and matrix keypad we use. Analog inputs also use. First we studied this LEDs, digital keypad, interrupt, timers, clock, SSD, and matrix keypad, and analog inputs. First we know this components means we can do the project easily. That's why in internship, after introduction to C, we studied this. Next, now let's see the in detail. First, LED. LED is the simplest device used in most embedded applications as feedback. Works on like diodes. Low energy conservation, longer life, smaller bit, faster switching, make it usable in wide application fields. Example: home lighting, remote control, surveillance, displays, and many more. Next, LED is an external device connected to microcontroller port. A port is interface between the controller and external peripheral. Based on the controller architecture, we have a number of ports. From schematic, we come to know LEDs are connected to port B and port D. Port is a peripheral, and we need to know how the access and address. This info will be available in the datasheet port B, port D, and data memory sections. Next, from the section of port B, it's clear there is one more register associated with named as TRISB. The TRISB register is very important for IO configuration. The value put in this register would decide the pin direction as shown below. These are TRIS register, port register, and pin direction. If you taken 1 as TRIS7, it taken as register 7, and 1 it shows the input and 0 shows the output. For TRIS1 is RX1, that means register 1, and if it is 1, this is considered as input. If it is 1, this pin direction is input, and TRIS7 is considered as register 7, same as like this. Next, this is the LED, and which side is work means positive side we are connected to VDD, and negative side is considered as ground. This one longest pin as a positive, and this is shortest pin as negative. Next, this is different LEDs connected to single switch. This is the figure. Next, tactile switch. Considering this design, what will be the input to the microcontroller if switch is pressed? If switch is pressed, what will be the input to the microcontroller? if switch is pressed, it is connected to the ground, and VDD also present. uh, will this solve this problem which may arise in the design mentioned in previous slide? For this we are using a register. If the switch is on, it connected to a microcontroller. If switch is off, then register should store the energy, and whether the switch is off, from this register it can load. For this we are using the register. Now this problem is solved. Now we are interchanging the switches and consider as two registers are used, R2 and R1, and switch is used. Next we studied about the tactile switch bouncing effects. When switch is pressed, it takes the contact bounce period, and when switch is released also, it takes the contact bounce period. Because if we see this figure, it contains a metal plate and terminal. If you are switching the plate, the metal plate will bounce. That's why we are getting the bounce effects while pressing and releasing. This is the figure. See, when switch is pressed also, we are getting the contact bounce period, and when switch is released also, we are getting the contact bounce period because of metal piece, as we shown in the previous slide. Next we studied the interrupt, basic concepts of interrupt. An interrupt is a communication process set up in a microprocessor and microcontroller, in which an internal or external device requests the MPU to stop the processing. This is known as interrupt. The MPU acknowledges the request, attends to the request, goes back to the processing where it was interrupted. Next in this polling. Next, interrupt classification. Interrupts are two types, software and hardware. In this hardware, and again there are two types, non-maskable and maskable. In this maskable, external and internal. This is the classification of interrupts. Next, interrupts handling. In this interrupts handling, there is a super loop and interrupt handler. Super loop becomes considered as addresses, that is we looking for 0x0000 and up to end. This is taken as increasing order, that's why I, and next one is I plus 1. If I sends I got the interrupt, then it sends to the interrupt handler as shown in figure, see like this. And next interrupt handler gives the solution for and to the next. That's why we are taking as I and I plus 1. Next we studied about the ISR. ISR means interrupt service routine. It is similar to a subroutine. Attends to the request of interrupting source. It clears the interrupt flag, and it should save register contents may be affected to the code in the ISR. Must be terminated with the instruction readfee. When interrupt occurs, the MPU completes the instruction being executed, disables the global interrupt enable, places the address from program counter on the stack, as we show in previous slide. That is the figure, and we are describing that in these words. Next, return from the interrupt. Next we studied the CLCD. This is the figure of CLCD. CLCD is the character liquid crystal display. It is the full form of CLCD. In Pixim lab there are two types of display, 16:2 display and 16:4 display. In display, the ASCII character and special characters. It is most commonly used to display two types of common communication modes, 4-bit mode and 8-bit mode. We study about two modes. And next, coming to the timers, resolution, register width, and tick. We studied resolution, tick, quantum, scaling, modes, counter. In this resolution, it tells about the register width, and tick it tells about the up count or down count. Next, quantum it tells about the system clock settings, and scaling tells about the pre-scaling or post-scaling. Next, we study about the modes and counter, and here using about the PWM or pulse generator. Next, PWR PP instruments. These are the introduction to the timers we studied in this internship. Next, uh, timer is an important application in the embedded system, which is default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating displays, etc. Timer or counter is a software designed to count the time intervals between the events resolution, which is also called a register width. Register width is taken as 8 or 16 bit. Uh, Ticker is referred as the change from one number to another number. It may be up count or down count. And quantum, which depends on the clock system clock settings, is measurable of time, which is responsible for the tick. And scaling may be prescaler or postscaler. That means 1:1, 1:8, and modes of timers. Coming to the project, let's get into the project demo. These are the contents: introduction to black box, features of black box, why it is required, requirements, embedded system, Pixim lab, car black box, project implementation. Starting introduction. First, in this internship, we are doing the car black box project. First we know what is in the car black box. A car black box is either physically installed in the car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance travel, driving frequency, and time of the day is in the motion. Next, features of black box. Exposure to a 1110 degrees or centigrade for an hour and 260 centigrade for 10 hours. It can operate between -55 to +70 degrees centigrade also. It can carry a minimum of 25 hours of flight data. It is submerged under the equivalent of 6,000 meters of seawater for 1 month. And why it is required? The black box records an abundance of data. EDR have been voluntarily installed by many vehicle manufacturers since 2002. However, that specifies the data recorded. Amount recorded means amount and type of the data is recorded, varying depending on the manufacturer. It depends on the parameters like vehicle indicated speed, engine total percentage, brake status, ignition cycles crash, safety, best status driver. Requirements: knowledge on embedded C. That's why you study in this internship, starting basic concepts of C, and MP Lab IDE, X8 compiler, Pixim Lab. In this Pixim Lab, default screen, login screen, main menu, view log, set time, event capture. These are the requirements. Coming to the project implementation, already I done the project implementation. These are the outputs. If we take in the first this one, the taken as time. E it represents the event. SP is represent the speed. It shows the current time, and event is on, it shows the speed. These are the figures. Next, first is on, next is neutral gear, next is reverse gear, next is collision. Collision happens between the when it is in danger. Next, if you for seeing the records, first we type the password. Next, after entering the password, it shows the view log, clear log, and change the password. 3 options. From this view log, we can see the recorded sections up to 10 events. These are the project implementation. Now we see the conclusion. The possibilities are numerous and can be explored further if this technology can be put into the practical use. This is the conclusion. Now we will see the project implementation. This is the MP Lab XID. This is the car black box project. In this already I told we are using the ADC, CLCD, digital keypad, and DS1307 I2C timers. That's why we studied the basic concepts of this, and we are writing the code. Source files as .c files and header files as .h files. We are creating the project as car black box, and we are writing code. This is the car black box def.c. This is the code, and we are setting the password here only. This is the run option. We can run. After running, it shows the build successful. um, that means now we are writing the code and it running successfully. Now we are using the Pixim lab for putting this code into the that microcontroller. Let me wait. This is the Pixim lab. This is the Pixim lab tool. Already I shown in the PPT. This is the CLCD and this is the LEDs. This is the potentiometer. This is the digital key. This one. This is a digital keypad. We are using these three switches and these three switches. Next, now here this is the file. This is the loadx file. Now here this is the .x file. Now we are doing this. If you load this one, it shows the in CLCD time, event, and SP means speed. It shows the current time 12:33 hours, minutes and seconds, and event is on. This is the speed. We can vary by using the potentiometer. This is the potentiometer. See, now I am varying speed to 4. Next, these are the switches. By using these two, we can shift the gear. Now event is on. By clicking this is neutral, this is reverse, and this is gear 1, gear 2, gear 3, gear 4. When it is danger comes, it will gives the collision by pressing this. And next we can shift by using upward also. Coming to the previous, this is G4, G3, and this is the collision. If you want to see the recorded events, by pressing this RB4, RB3, RB5. See, if you see, I told previously we are giving the password. I set password as 2424 2424. After we are giving the password for we are giving the password for security purpose. This is the view log and this is the clear log. By using these switches, we are coming down and up. This is the clear log and change password. First we see what are the recorded events. As we now we are using these switches, we are doing recorded events G1, G2, and neutral, reverse, and collision. Now we see by clicking on this RB5, we can select the view log. This is the first event 0 and on. Speed is 0. Next, by clicking RB4, this is the first one. Recorded section, recorded event 1234, neutral with speed 4. Next, event 2 reverse. Next, G1, G2, G5, G4, sorry, event 6, G4. Next, 7 at collision. These are 8. These are the 8 events I recorded. Next, coming back this, these are the events. And come another also, if we see do not entering the password, after 5 seconds it will come back. Let's see. And also now we will record one more time and collision also. Next we are entering. If you type only one letter, only one bit, now password is 4 bits, and only you press 1 bit, it comes after 5 seconds back to the position. See, 4 3, I give only 2, then it come back to previous. See, Again we're entering, typing the password, correct password. Now we're already we done view log files. See, these are the recorded events. We are seeing that this. Now we'll clear the log files. These are the events recorded. Next we see already we are using the view log files, entering password. Now we are recorded events must be clear now. For that we are selecting the clear log and using RB5. Yes, now logs cleared successfully. See, now if you view the view log files, that was showing no logs because already we are clear. And also now we will see we are entering the correct wrong password. It will shows like this, wrong part. Only we are giving 3 attempts. Already 1 attempt is over. Next 2 attempts remain. Next we are entering wrong password. 1 more attempt is there. If we again we are giving the wrong password, it will block up to 60 seconds. See, again I am giving, you are blocked. Like phone also, if you are not giving the password, it will block. Here also we are blocking the event for 1 minute. And third option is also there, a view log file, clear log, and one more is there, change password. After getting this over, this 50 seconds over, we will see that one also. Okay, by selecting the change password, we are changing the password, and it will display here your password is changed successfully. This is the internship project, and these are the things we studied in this internship. Thank you.